Rahul Prabhune, and I'm going to walk you through unsupervised machine learning problem. And the data set that I've picked up is the credit card fraud detection. The reason I've picked up this particular data set is because I've been working in finance industry for last 20 years, and I've worked on these products as an engineer. So I have some domain knowledge around it. So this is a binary supervised and unsupervised classification problem that we are trying to solve. So what we are going to do is we are going to first, look at how the model performs on supervised models, all right, based on the training data set and the test data set. Look at those particular parameters, and then we are going to, implement unsupervised uh, machine learning um, algorithms and models to see how they are performing. And at the end of the day, we are going to combine these two models together, which is unsupervised and supervised, to get the best possible results in terms of accuracy, precision, and recall. So so I'm going to walk you through the project. So we have this data set that I'm loading from the Kaggle, and then printing out the data size for that, doing some data cleaning, looking at the head, looking at the info. We have V1 to V28. So this particular data is masked, and that's why you don't have, let's say the location, your credit card user information and whatnot. You only have like, so these are all like legend feature parameters, right? But they are masked, so you only have V1 to V8 or V28, which is good enough for us. And then we have amount, which is the amount of fraud that has happened. And then we have, is fraud, is this particular transaction that has happened is a fraud or not a fraud. And this is what we are trying to predict. Okay, so this is our y, which is what we are trying to predict, and these are all our other are all our features. Based on that, we are going to predict our is fraud or not. So we have, so here I have done some cleaning up in terms of, if we have duplicates, I've removed them over here, and there are no nans in the data set. So the data set seems to be fine. Um, the amount of in the EDA, what I found out was the data set is completely imbalanced. What I mean by that is the number of frauds that we have are only 473 versus the number of non-frauds we have is huge. It is like 283,000 non-frauds, right? So if we had 50% frauds, 50% not frauds, then the data set would be balanced and the accuracy would be better. So that's the challenge that we are trying to solve over here, because the data set is so imbalanced that we need to fight it a bit to get the right data. So this is how the normalized data looks like for each and every feature. So when I say normalize, you see the 0 is where you have the highest, and then it goes down on both sides. So from V1 to V28, everything seems to be fine in terms of it's normalized, but the amount is not normalized because there are a lot of outliers over here, which is like 25,000 and whatnot, right? So we need to normalize this particular field. If you look at is fraud, we have, you know these are all the non-frauds, and then we have some frauds over here which you cannot see, but that's our why we don't care about that. So this is how our distribution looks like before we normalize it as part of our feature engineering. And then I did some feature engineering where we are actually removing the negatives and whatnot, and doing like uh, doing robust scaler to reduce the sensitivity of the outliers. And then once you do that, you have something which is normalized. So all your values are now between minus 3 and 1.5, which is good for a feature set. Then I've also checked for collinearity, and none of the features are highly correlated, so we are good over here. And yeah, so and then I'm splitting the data between training data set and the test data set. And this is again, we are first trying to look at supervised learning. So trying to find a hyperparameter for a random forest classifier first over here, and then summarizing that, picking the best parameters and then running the data set um, to find the find what is the precision and what is the recall. So we have 0.84 and 0.8, which is the recall, which is a decent score right now, which I'm pretty much happy with at this point of time because our data set is very imbalanced. So these numbers make sense. And then this is a diagram for that. And then we have another supervised learning model, which is gradient boost classifier, just so that we can compare or know what are the scores for that. So again, the same hyperparameter tuning for that. And then these are the results, which we are getting a little bit of less precision, and then the recall is a bit high on this. But we need to match, we need to look at these numbers, because once we now are going to jump on to unsupervised uh, model, which currently I'm using over here. Then we can look at things. So I'm using um, isolation forest as an unsupervised training model over here. And first I'm doing hyperparameter tuning to find the right parameters uh, which are going to give the best results for the model. So I'm using random search CV to figure out what are those best parameters. And now I'm getting those best parameters over here. And these these are the best parameters that you see over here, right? And then I'm pushing those particular parameters in this particular line. Yeah, this particular line, right? I'm getting these particular parameters and I'm calling this model on these parameters over here to fit the training data and look at the score. Now, if you look at just the score for unsupervised learning is, this is pretty low. The reason is, before in supervised learning, we were using is fraud as our training data set, which was 0 and 1, which actually gave us the result, right? But with unsupervised learning, we are not at all considering that particular is true. So if you read this particular piece of how we are doing is, it's without the fraud labels. We are trying to get the raw distribution of the data, and based on that, we are trying to separate out the different clusters in a way where we are not using the labels as fraud is fraud. We are not using that. So we are completely trying to looking at just a feature set. We are trying to divide those particular sections to see whether we can actually find an equilibrium where you can identify frauds and not frauds. And because it has not, it is just categorizing that, it has done pretty poorly in terms of these scores, whereas supervised learning was pretty strong, right? It had better scores. um, but then what I did was, I actually used the score, the training score, and I added that as a feature parameter inside our supervised learning dataset. So I'm using the random forest plus score, the score that I got from the supervised learning model as an add-on feature to it, and I added that, and now I'm running random forest over here, and my precision has improved over here. And so what I've done is, I have you know used unsupervised learning model to feed extra parameter to the supervised learning model to improve the performance of our model overall. And this is exactly what is mentioned over here. So what this means is, this is the best model performance that we have got, because we did marry unsupervised learning with supervised learning to get the best results. So 86% of the time the model prediction is going to be correct, that the particular transaction is not fraud, and 14% of it's going to flag as when it is when it is not a fraud. That means you're going to get 14% of the time you're going to get false positives. So the customer might get a phone from the bank that, hey, this might be a fraud, right? So, but still it is a very low number. And then the recall is when 80% of the frauds we are going to detect and 20% of the frauds we are going to miss. And this is a really good result considering that we have such a imbalanced data set to begin with. And then if you like, this is just a first step. Like in any of the applications, then after you have flagged a particular card, there are more robust systems in place where there's data reconciliation, reporting tools, and technologies and processes to actually confirm that, okay, fine, whatever has been flagged as fraud, is it really fraud? Or whatever this model has missed catching up the fraud, there are other systems, robust systems in place to catch that last 20% of the frauds that are not caught in this particular cycle of supervised and unsupervised model prediction. Yeah, that's it. Thank you so much for listening to this.